Hello everyone. For this video, we will talk about what is greedy algorithm. An algorithm is designed to achieve optimum solution for a given problem in greedy algorithm approach. Decisions are made from the given solution domain. As being greedy, the closest solution that seems to provide an optimum solution is chosen. Also, greedy algorithm always makes the choice that looks best at that moment. It's not going to be very good at getting optimal solution, and the reason why is that greedy algorithms are going to make that we call locally optimal decision. And I'd like to call this algorithm the infant algorithms because they're essentially going to make decisions like a 5 years old kid. If you give the same problem to the algorithm and you give it to a 5 years old kid, they're probably going to come up with the same solution, which is probably means it's not going to be a very good algorithm. There's going to be for greedy algorithms, or sometimes where they will give you the best solution, but most part they're going to make the best possible decision at each step. Now once again, that seems pretty good, but I'm going to quickly show you that it's quickly become a problem. So in this part, I will show you if there is a diagram and you want to reach from A to C, so you need to think what is the best solution from reaching C. So next step is E to B, this one A to B, and A to C, A to D. So A to B is 3, A to C is 8, E to D is 4. So in greedy algorithms, you want to choose the quickest path or the shortest path to reach your goal or the C. And the lowest step is the A to B, which is 3. So you need to choose the 3 and then 1 to reach this. So this is the answer, which is the quickest way to reach the C using greedy algorithms. But it doesn't happen every time that you choose a greedy algorithm and you get the best solution. Like for example, in this Crodley map, this assuming this is a kid and this kid want to reach from A to B using greedy algorithm. So when using greedy algorithm, it will select the quickest or the shortest way to go to B. So it obviously this kid gonna choose the 30 because it is the lowest from 50. So in this part also, when showing that this kid will choose this 30. So in this part, 75 and 80, the lowest is 75. Also, this part is 80. So there are 3 choices, which is 75, 10, and 15. So the lowest one is 10. So we're gonna choose this path. That's the path that the kid is going to use, and we're going to see that that's not the definitely going to be the quickest path that he could have taken. But if you went in this path or in this route, 50, 25, 30, 10, you will get the quickest way to reach the B. So in this example, I hope you understand what is the greedy algorithm. So I've said earlier that greedy algorithm is not always right or can so this is the sample application or the example application of the greedy algorithm, which is the activity selection problem. Activity selection problem is an optimization problem which deals with the selection of non-conflicting activities that needs to be executed by a single person or a machine in a given time frame. Each activity is marked by a start and finish time. Greedy technique is used for finding the solution since this is an optimization problem. So what is activity selection problem? So let's consider that you have activities with the start and finish times. The objective is to find solution set having maximum number of non-conflicting activities that can be executed in a single time frame, assuming that only one person or machine is available for execution. I have a table here. Example of selection problem activity selection problem. So in order to solve this problem, so this is a start time and the finish time of these activities. So the next step is you will have to sort it. Pastaro na to ini from the finish time. So the next step is we will select the first activity from sorted array. So the first activity in sorted array is activity 2. So we will add it to the solution. And the next step is the next activity, which is the activity 3. So if the start time of the currently selected activity is greater than or equal to the finish time of the previously selected activity, then add it to the solution. Since the start time of activity 3 is greater than the finish time of activity 2, so we can add it to the solution because the start time of activity 3 is greater than the finish time of activity 2. Their schedule or their time is not conflicting, so we can add it to the solution. So the next activity that we will select is the activity 4. So it obviously the start time of activity 4 is less than from the finish time of activity 3, so we can't add it to the solution because their time is conflicting. And the next activity is activity 5. Since the start time of activity 5 is greater than the finish time of activity 3, our previously selected activity, so we can add it to the solution because their time is not conflicting. So the next activity, the activity 1, since the start time of activity 1 is less than from finish time of activity 5 or previously selected, so we can't add it to the solution because their time will conflict or have a problem. So the next activity, the activity 6, since the start time of activity 6 is greater than from our previously selected activity, the start time of activity 6 is greater than from the finish time of activity 5, so we can add it to the solution. Their time will not conflict. So these are the activity that the execution schedule of maximum number of non-conflicting activities will be activity 2, which is 1 to 2, and activity 3 3 to 4. Next one is activity 5 to 7, and activity 6 8 to 9. So these are all the answer of this problem. So I hope you understand what is activity selection problem and how we can solve it using greedy algorithm.